Modern marbles. When it comes to having a long lifespan, few things can compare to what most of us know as styrofoam. But this familiar foam product actually has many different names and uses. And whether you're getting takeout or your morning coffee, the squeaky white containers are universally known for their durability. Foam packaging, derived from petroleum-based plastic, does not biodegrade or disintegrate and can remain in landfills for centuries. That longevity has raised some environmental concerns, but it's exactly why foam is being used in surprising ways all around us. Foam has spread beneath our feet, to roads, bridges, even airport runways, and it's built to last.
EPS foam is incredibly strong. It has a PSI, pounds per square inch, of 25 pounds for a compressive resistance, which means that a square foot of foam has 144 square inches. It will hold approximately 3,600 pounds. It can hold tremendous amounts of weight before it fails.
You can almost imagine a world entirely made of foam. EPS foam, or expanded polystyrene by its more formal name, is a moldable plastic when heated. It's most recognizable in packaging for food or fragile purchases, like electronics. But here, foam is really coming to life to help support, literally, the nation's roads. The 1956 Federal Aid Highway Act, creating the nation's highway system, called it essential to the national interest. And it's expected to be there when we need it. Today, the nation's highways and roads are used by hundreds of millions of vehicles a year, resulting in annual maintenance costs of over $40 trillion. Block by block, in projects across 40 states, foam is paving the way to toughen those roads for the long haul.
EPS foam has replaced soil where they have unsuitable soil if it's muck or if it's swampy land. That's always, the road's always kind of given away after 4 or 5 years. They just decided to pull all the old soil out and they'll put EPS foam down there.
In road projects, on top of a gravel base, layers of the special geofoam are stacked, anywhere from 2 to 20 layers tall. A rubber membrane is laid over the geofoam to protect it from any road liquid or fuel spills. A final layer of soil is placed on top before the asphalt makes the road complete.
Dirt fill is about 100 to 120 pounds per cubic foot compared to foam, which is 1 to 2 pounds per cubic foot.
A simple demonstration outside shows just how durable this seemingly lightweight material really is. These small foam ramps will prove they're all muscle.
So this foam here is 96% air. It weighs less than 10 pounds and it's capable of holding a truck that is in excess of 7,200 pounds and is very, very strong, as you can see.
The foam has the same properties as the packing peanuts we're used to seeing all over our floors, just a more compacted form with less static and a different name.
Most people refer to this as styrofoam. Styrofoam is a brand name by Dow. This is actually expanded polystyrene, but just like everything else, like Kleenex, it's a brand name and it just sticks with it.
So how does this chameleon-like wonder come to life? It starts small.
These beads, before they come to us, they're processed in reactors, and they're 15,000-gallon reactors, and styrene is a liquid. They dump about approximately 6,000 pounds of styrene in here, and they dump about 3,000 pounds of water, and it's just like oil and water. They don't mix. The faster you agitate it, the smaller the balls you get, and that's where we get these small beads.
The beads then begin a multi-step process, which starts at the pre-expander. It's here that the beads begin their amazing physical transformation, when the pentane inside them changes from a liquid to a gas.
The polystyrene sits on the floor, and the steam comes up from the bottom of the floor, and that's what reacts with that pentane. The beads get conditioned, they get worked, that bead gets soft, and it starts to expand. With that pentane gas releasing, the beads expand.
The beads ultimately grow to 40 times their original size. The machine can be set for different recipes based on the amount of beads used. A lighter mixture would be made for packing materials, a denser, tougher one for road use.
The higher the density, the stronger it is, the more weight there is, the more wear and tear it can have.
The beads then take a break in storage silos, where they lose some of their pentane gas, making them easier to mold into solid forms. The block mold with its internal vacuum is where all the action happens for the foam's final metamorphosis. It's where the hyperactive beads start to take on their new role as usable, durable foam.
We're going to stick it in the block mold, and we're going to make a 2 foot by 4 foot by 16 foot long block. The beads are going to get together, and when you hit it with heat, steam, it's going to want to expand, but there's nowhere for it to go. So what it's going to do is it's going to mold itself together. It's going to fuse itself together, and you're going to have finished block when you're done.
The final blocks often tower over the workers who move them. They are now tough enough to support major highway projects. Or they can be sliced down thin enough for delicate packing material. Another reason the finished product is built to last is its recyclable properties.
We recycle probably over 500,000 pounds of EPS a year in our facility. We take it back from consumers. We got a lot of post-consumer product here. Take it back from appliance stores. We recycle 100% of our stuff.
Over 69 million pounds of EPS foam was recycled nationwide in 2008. And it can be reused in some rather unexpected ways. Recycled foam is found in CD cases and even plastic hangers.
It's melted down and it's got a mold, and they inject the melted foam right in there and they cool it down, and out pops a hanger.
But foam's long-lasting use in roads and bridges could be its most valuable legacy.
It doesn't disintegrate, it does not break down. It's just like it was if you dig it up 20 years from now. It's the same as when you put it in the ground. Foam is here to stay. It's built to last.
Foam may be built for survival, but it's not the only thing made to go underground that's expected to last.